So we already said number one had a GCF, and we said the GCF was 5 and x. Okay, 5x. And then once you take out the 5x, what is left over? 2x plus 5. Okay. And then we said number 2 was a bit different this time. It still has difference of squares, but it has a GCF before difference of squares. So what GCF do you guys see that we could take out before difference of squares? 3. We can take out a 3. And what does that leave us with? X squared minus 25. And then we have to do difference of squares. So we're going to have 2 parentheses, one with a plus, one with a minus. And what does that put in those parentheses? We have, yeah, x plus 5, x minus 5. So you're right with the 5 and 5. Yeah, x plus 5, x minus 5. Okay. And then what about the third one? The x thing, yep. So multiplying to 42, adding to negative 13, and the numbers are negative 6 and negative 7. Doesn't matter which order you put them. So x minus 6, x minus 7, or x minus 7, x minus 6. Either one is fine. Okay. The next one has a cubic graph, and if you graphed that on Desmos, it looks something like that. So what is the domain? What is it from left to right? How far left, how far right? Negative infinity to infinity. Arrow to the left, arrow to the right. How far down, how far up? Negative infinity. Yep. Same thing for the range. Okay. If we put a stick figure on it, is the stick figure walking up or down? So if we start walking, which way are we walking?
Negative infinity.
Yeah, we're walking, this is a left arrow, so that's a negative infinity. That's a positive infinity, but are we walking uphill or downhill? Uphill, so this is increasing. And it's from negative infinity to positive infinity. Okay? The left arrow points up or down? Down. The right arrow points up. Okay. All right, for G, we're going to plug in negative 2. So we've got negative 2 squared plus 8 times negative 2. What do we get? Negative 12. Good. We're going to take function k, and we're going to plug in 3y. So I've got negative of 3y squared plus 3y. So negative of 3y, I'm going to write this twice. Plus, I don't really need those parentheses. And then what is the negative version of 3y times 3y? Negative 9 y squared, right? Y times y is y squared. And then we have a plus 3y on the end. And can we add these together? We cannot, because we've got a y squared and a y, and those are not like terms. Okay? Next, we have function h, and we're supposed to take the x out and plug in m minus 4. So negative 3, take the x out, and then plug in m minus 4. Okay? And then what do we do with the number in front of the parentheses? We distribute the number in front of the parentheses, okay? And what do we get? Negative 3m plus 12 minus 4. What does that give us? Negative 3m plus 8. Okay? And then over here, what does this notation mean? Yeah, multiply. The little dot in the middle is telling us to multiply. So we're going to take f of x, and we're going to take h of x, and we're going to multiply them together. So f of x is 2x plus 1. H of x is negative 3x minus 4. And how do we multiply two sets of parentheses? We FOIL, okay? So we're going to multiply the first times the first. What is the first times the first? Negative 6x squared, okay? Then we're going to multiply the outsides. So what do we get when we multiply the outsides? Negative 8x, good. Okay, then we're going to multiply the insides. Negative 3x, Okay, then we're going to multiply the last. Negative 4, okay. And if we put all of that together, there we go. All right, make sure your name is on your warm-up and get your warm-up turned in. All right, so inverse operations are operations that undo each other.
Oh, so like add and then subtract.
So examples are adding and subtracting.
Divide and multiply.
Divide and multiply. Another example that you have probably seen is taking a number and putting an exponent of 2, squaring a number and square rooting a number. So squaring and square rooting.
I just drew the square root.
Yep, you can draw it, that's fine. So you could say like x squared and square root, something like that if you want to draw it like that. And inverse notation looks really specific, so we want to write down if the original function is written a certain way, we want to write that the inverse is something else so that we can tell them apart. So if the original function said y equals, then the inverse function would be written as, we say it out loud, we say y inverse, but it looks like an exponent of -1. That's not how you read it. You literally say y inverse, but it looks like an exponent. If the original function was f of x, then the inverse notation is f inverse of x. If the original function said g of x, then the inverse would be g inverse of x. So you always match the notation of the inverse to the original problem, so you know what they go with. So for today, we're going to start off with finding inverses of linear functions because those are basically the easiest functions to find the inverses of. And the steps are pretty simple. So when you're finding an inverse, the very first thing that you're going to do is you're going to trade the x and the y, the variables, you're going to trade them in the equation. So x equals -3y plus 5. You're going to trade the x and the y. And then what you're going to do is you're going to solve for the y. You're going to try to get the y alone. So what I would do first to get the y alone is I would subtract the 5 over to the other side. That's the easiest thing to do. I'm going to subtract the 5 over. So I have x minus 5 equals negative 3y. And then to finish getting the y alone, I would divide by negative 3. So I end up with y equals x minus 5 over negative 3. Now, to make this answer look correct, I need to make sure that since my original problem says y, my final answer needs to say y inverse. Also, a lot of students don't like that the y is written on the right side. Are you guys uncomfortable with that it has the y on the right side? Yeah? So we can rewrite this equation. We can say our final answer is y inverse, because our answer, if it's an inverse, it has to say that. Our final answer is y inverse equals x minus 5 over negative 3. Okay, let's try the next one. So f of x is just another way of saying y equals. So in this problem, I'm going to think of f of x as kind of like being a y value. So it's kind of like the y. So again, the first thing I'm going to do is I'm going to trade the x and the y. So x equals 1/2 y plus 1. And then I'm going to get the y alone. So if I want to get y alone, what's the first thing I could do? I'm going to move the 1. So I'm going to minus 1, minus 1. So I have x minus 1 equals 1/2 y. And then to get rid of 1/2, you could divide by a fraction, but that's kind of uncomfortable. So most people, instead of dividing by a fraction, they would just multiply by 2 instead, because multiplying by 2 would get rid of the fraction. Does that make sense? Multiplying by 2. Now you could divide by a fraction, it's just not quite as comfortable. So when we multiply by 2, we have to be careful to make sure that the 2 gets multiplied by the entire thing. So 2 has to multiply by everything. So if I take the 2 and I multiply it by everything, what do I get? I get 2x minus, 2x minus 2. Now, the 2 over here and the 1/2, they canceled out, right? 2 times 1/2 is just 1. It made the 1/2 disappear. And my y is all alone. And since I solved for y, this is the inverse. All right? Now, the original function wasn't called y. The original function was called f of x. So for my inverse function, I'm going to say the name of this inverse function is f inverse of x. And the inverse function equals 2x minus 2. Okay, on this one, here's g, this is a y. What's my first step? What's my first step? What do? I trade the x and the y. And then what do? I'm trying to get the y alone. So what could I move over to the other side? I'm going to add the 7 to the other side. So I get x plus 7 equals 4y. And then how do I get the y alone? Divide by 4. So I have y equals x plus 7 divided by 4. Now I have to write this down so that I know that this is the inverse function. So if the original function was called g of x, what am I going to call this function? G inverse. G inverse. So I'm going to say g inverse of x is x plus 7 over 4. Okay, what's our first step on the last problem? Trade the x and y. Okay. And now what do we do? Add the 8 to the other side. So x plus 8 equals negative y. We want the y to be alone. So what are we going to do? It's almost alone. Divide by negative 1 because you don't want to have that negative there. So divide by negative 1. Now if we had a number on the bottom other than 1, then we would just leave the number on the bottom. But do we know how to divide by negative 1 with these two? What happens when you divide by a negative 1? Yeah, it changes the signs, right? So a positive x would become negative x, and a positive 8 would become negative 8. Okay, and the y is all alone. And then do we leave it as just y? No, we have to have special notation. What does that notation look like? The negative 1, it's the inverse, right? So now we say y inverse is negative x minus 8. Okay, so this is what we're doing today. We're not going to do any more of the notes. You're going to save the notes in a safe place. Leave them out for now. Don't put them away. We are going to practice just this. So I'm going to hand out the worksheet.